Okay, so we're going to get started. We're going to determine if these are functions or not, and we're going to look at 4 different ways that we can write relationships. Okay, so we're going to look at ordered pairs, a table, a mapping diagram, and then a graph. So from all 4 different representations, we will be able to determine if something is a function or not. Looking at this paper, let me just kind of go through how you would read it. So we're going to look at this column right here, ordered pairs. This is an example of a function. And where it says non-example, this is not a function. So all the ones on the top are functions, and all the ones on the bottom are not a function. Okay? And we'll go through one by one and talk about what makes them a function and what makes them not a function. Okay. So looking at ordered pairs to begin with. Okay. Looking at ordered pairs. So in the middle, it says the x values must all be different. That's the word that's going to go in the middle there. So go ahead. You're going to write different in that space. So the x values must all be different. Let's take a look at these examples. So if I look at the one that is a function, okay, is my x value the first number in the parentheses or the second number? Anybody? Okay, so your x value that you're looking at is the first number. Go ahead and circle all the first numbers. Okay, those are your x values. Those are your input. That's what you plug in, remember, and then what you get out is your y value. That's your output. Are these all different? Is there any that repeat? Are the numbers all different? Yes, that's why it's a function. Do we care about the y values? No. We only care about the x. So we're only looking at our input. Are all the inputs different? Yes. Let's go ahead and look at this next one. Go ahead and circle all of the inputs or all the x values. Do any of the x values repeat? Yeah. Which ones repeat?
5.
Yeah, the 2 5s. The 2 5s repeat. So these 2 repeat. So these 2 repeat. So if they repeat, then it's not a function. Okay? If they repeat, it's not a function.
What about the one over there?
What do you mean?
Here?
Yeah. We'll get to the mapping. We'll get to that one. Okay? So when we're looking at ordered pairs, we need to look at the first number. If they repeat, it's not a function. They have to be the exact same number. So 5 and 5. -2 and -2. Questions there? Okay. Let's look at the next example. So tables. Tables are just another way to write ordered pairs. As you can see, instead of writing it as parentheses 2, 6, we could write it as in the table as 2 and 6, and so forth. Okay? So again, for this one, we're looking at our x values. We need to look at our x values. Are any of them repeating? No. What about do we care about the y values? No. We're only looking at the x. None of them are repeating, which means it's a function. The x values all must be different. Let's look at the ones that are not, the one that's not a function. Is there any that repeat? The 2's are repeating. Exactly. So it's not a function. Questions about this so far? Okay. To kind of give you somewhat of an understanding, let's say you're going to a vending machine or like a pop machine. Okay? If I click on the Coke button, what's going to happen? I put my money in and I click on the Coke button. What's going to happen? You're going to get a Coke, right? Okay, so I click on the button, I get a Coke. If I click on that same button and I get a Sprite, is the machine working? No, it's not a function. We can't have the same one and have something different come out. Okay? I can't click the Coke button and get a Coke one time, click it again, and I get a Sprite. We would say that that's not working. That machine's not working. So it's not a function. Okay, mapping diagram. So with the mapping diagram, again, we need to look at our x values, and remember our x values are our input. So our input is what we're looking at here. I wish I had a little bit more room. Okay, so if we look at this, if I input 2, what do I get? If I input 2, what do I get? 6. Good. If I input 4, what do I get? 3. If I input 8, what do I get? 7. Good. And if I input 9, I get 12. And if I input 13, I get 10. Okay, are any of them repeating? We could look at it this way. No. The other way you can look at is there's only exactly one line that comes from all of these. So one line from the 2, one line from the 4, one line from the 8, one line from the 9, one line from the 13. So for every input, there can only be one, I want to do this in black, one output. Okay, so I put this in, I only have one thing coming from it. Now let's look at the one that's not a function. If we look down here, and we're looking at the inputs again. If you just look at it, yeah, okay, these are all different, but that's not what we're looking at. We got to look at what our outputs are. So for -1, -1, what's my output? If I plug in -1, what do I get? 5 and 8, right? So when I plug in -1, I get 5 or 8.
Oh,
That's repeating right there. You see how there's 2 lines coming from it? If I push that Coke button and I get a Coke, and then I push and I get a Sprite, it's not working. So the 2 lines coming from the -1 tells us it's not a function. So the 2 lines coming from -1. So right here, that's what makes it not a function, because there's 2 lines coming out of it. Questions with that? Okay. Next one. Let's talk about the vertical line test. So vertical line test. If a vertical line touches or intersects the graph at more than one place, it's not a function. So let's look at what this means. Whoops. Let me actually get the line tool so I can make straight lines. Okay, so no matter where I put a vertical line, which is a line that's straight up and down. Let me make it a little bit thicker. Sorry. Okay, so if I put a vertical line here, how many times is it touching my graph? So if I look at this, it's only touching the graph in this one spot, right? We see that? So it didn't touch it in more than one spot. If I were to, and I could draw another vertical line, like right here. Again, when I look at it, it's only touching my graph in this one spot right here. You can put your pencil straight down and see, right? It's only touching it in one spot. Let's look at the one that's right below. Again, if I draw a vertical line here, which is a line straight up and down, notice it's touching the circle or the graph here and here. That's like your X is repeating. And I could test it here. And again, it fails. It fails the test, the vertical line test, because it's touching the graph in two spots. Go ahead and make sure you draw that on your graph, a vertical line. Show that it's touching in two spots. Remember, it has to be more than one. Maybe it's touching in three spots. Using this graphic organizer, we are going to complete the back side. So the back side, the first thing, there is multiple cards, A through P. This is letter L, by the way. And down below, it says that you're going to write the letter in each box. So this is either a function or not a function. So let's look at the first one, A. Is A first of all, what do we have to look for? The X or the Y values in the first one? X. So we're looking at the X values. Do any of them repeat? No. So is this a function or not a function? It's a function. So the letter A is going to go down here. And then you're going to go to B. And you're going to keep doing that until you get all of them sorted. Good, let's go over these then. So after A, what other one is a function? B, good. E, yes. F, I, yes. What? L. Good, and M, anything else? O is kind of difficult. We had some debate first hour about whether or not O is. This line looks like it's kind of straight, but it's not. So O, we're going to say is a function, okay? Which means all the other letters that we did not include, so that's C, D, G, H, J, K, N, and P are all not functions. Anybody have any questions about those? No? Okay. Then I would like you to get on your Chromebook and go to Delta Math. That's your assignment number 1.